Welcome to Unit 3, Lesson 2, Relative Frequency Tables. We have one learning target for today. I can calculate values in a relative frequency table and describe what the values mean in everyday language. A teacher asks their student whether they studied for a quiz, then scores the quiz. A relative frequency table displays some of the information they collected. So we have rows, passed quiz and failed quiz, and we have columns, studied and did not study. Notice that if we look at our rows, the rows add up to 100%. So this relative frequency table is set up as a row relative frequency table. The whole table doesn't add up to 100%. Each row adds up to 100%. And they ask, what does the 86% represent? So this 86% here is not 86% of everyone who was surveyed. This is 86% of those who passed the quiz. So this means 86% of students who passed the quiz and it's in the studied column, so that means 86% of students who passed the quiz also studied. So it's important that we pay attention to how the table is set up here. We want to know, is it the entire table that it's 86% of? Or is it 86% of a specific column? Or in this case, it's 86% of a specific row. The accessory choices of 143 people are recorded in the table. Create a relative frequency table that could be used to show the percentage of belt wearers who wear a watch or not, as well as the percentage of people without belts who wear a watch or not. So the way that they word this, we want a row relative frequency table. We want these categories to add together to equal 100%. And we want the no belt categories to add together to equal 100%. So for this box here, we're going to take the 62 and we're going to divide it just by the number of those who wear a belt. 62 plus 32 is 94. So we're going to say 62 divided by 4 times 100. And that is going to equal our percentage. So this is approximately 66%. For the next box, we're going to take 32 and divide it by that same 94 because we still only want to include those wearing a belt, and multiply it by 100 to get the percentage in this box. And that rounds to 34%. So 66% of those who wear a belt also wear a watch, and 34% of those who wear a belt wear no watch. And notice our percentages, 66 and 34, add up to 100%. That's what we want to see. Now we go to the bottom row and we want to know about those who do not wear belts. So we take this 29. 29 plus 20 is 49. So that's what we're going to divide by. Multiply that by 100 and we will get our percentage. So this rounds to 59%. And in this box, we're going to take the 20, divide it by the same 49, and multiply by 100 to get the percentage in this box. And that rounds to 41%. So this tells us 59% of those who do not wear belts do wear a watch, and 41% of those who do not wear a belt also do not wear a watch. And notice again our percentages in this row, 59% and 41%, add up to 100% of the possibility for the row in which they do not wear a belt. Scientists give 2 different treatments to people who have the flu and determine if their health improves. The results for the test are in the two-way table. We see that we have rows, improved health and no improvement, and we have columns, treatment 1 and treatment 2. Number 1, what percentage of people receiving treatment 1 had improved health? So when we're finding our percentages, we only care about the columns. So when we look at this first box, we need to take 23 and divide it by the total in the column. So what we're saying is we want to add these together and have it equal 100%. Then we're going to add this column together and have it equal 100%. So 23 plus 17 is 40. So we're going to do 23 divided by 40 times 100, and we're going to get our percentage. And that rounds to 58%. Now on the bottom left box, we're going to take 17, divide it by that same 40, and multiply by 100 to get our percentage. And that's 42.5%. So we should probably go ahead and go to 1 decimal place here. So 57.5%. And this one was 42.5%. And when we add these percentages together, we get our 100%. So, number one, what percentage of people receiving treatment 1 had improved health? That was 57.5%. Next, what percentage of people receiving treatment 2 had improved health? So now we're working down. We have 25. 25 plus 35 is 60. So we're going to divide that 25 by 60 and then multiply by 100 to get our percentage. And that rounds to 41.7%. And on the bottom box, we're going to take this 35 and we're going to divide it by that same 60 and multiply by 100 to get our percentage. 35 divided by 60 times 100. This rounds to 58.3%. And we want to know what percentage of people receiving treatment 2 had improved health. That would be right here at 41.7%. So if we were to look at these and try to make an interpretation, it appears that treatment 1 had better results because a larger percentage of people taking treatment 1 had improved health. A group of people surveyed about whether they have any brothers or sisters or are an only child and whether they have any pets. Which value could go in the blank cell so that the percentage of only children that have no pets is 37.5? So in this problem, we only care about the only child column. If we want 37.5% to be the bottom box, then it would have to be less than 105 so that it would be less than half. So what we can do is start with A, add that to the 105, and then find the percentage after dividing. So if we did 105 plus 63, 5 plus 3 is 8, 0 plus 6 is 6, and we bring down the 1. Now we can take 63, divide that by 168, and multiply by 100 to find out what percentage that would make. And we find out that would create 37.5%, which is what we're looking for. So the answer would be A. Many adults are selected at random to respond to a survey about their favorite season and whether they have allergies or not. The two-way table summarizes the results from the survey. Number 1, which season is the least popular in this group? So if we look, winter has a total of 64 people who prefer winter. Spring only has a total of 25 who prefer spring. Summer has a total of 68 who prefer summer. And fall has a total of 68 who prefer fall. So the least popular season in this group would be spring. Number 2. How many more people have allergies than people without allergies in this group? So now we need to add everyone who has allergies. 3 plus 2 is 5, plus 5 is 10, plus 3 is 13. Carry 1. 1 plus 4 is 5, 5 plus 1 is 6, 6 plus 3 is 9, 9 plus 3 is 12. So 123 people have allergies. Now we need to add everyone who does not have allergies. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 5 is 12. Carry the 1. 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 3 is 7, 7 plus 3 is 10. So 123 have allergies, 102 do not, and they want to know how many more people have allergies than people without. So if we want to know how many more people have allergies than people without allergies, we need to subtract. So we can say 123 minus 102. 3 minus 2 is 1. 2 minus 0 is 2. 1 minus 1 is 0. So this means 21 more. And number 3, how many people were surveyed in this group? So we should be able to add the totals going down, and we should add the totals going right, and they should be the same. So 4 plus 5 is 9, plus 8 is 17, plus 8 is 25. Carry the 2. 2 plus 6 is 8, plus 2 is 10, plus 6 is 16. plus 6 is 22. So adding down, we get 225. And if we add across, 123 plus 102 would also be 225. So this means 225 people. And the last question, a random sample of people are asked about their preferences regarding home decoration and their interest in fashion. Complete the two-way table so it has the characteristics listed. 150 people responded to the survey, so we need the 4 boxes to add up to 150. 70% of the responders do not pay attention to fashion. So we have 150 total. We're going to multiply that by 70%. And that's 105. So 105 people do not pay attention to fashion. 33 of the responders who prefer neutral decorations also do not pay attention to fashion. So we have 33 in the bottom right box. Now we know there was 105 who did not pay attention to fashion. So if we take 105 minus the 33 we just put in the bottom right box, now we're going to have 72 who do not pay attention to fashion but prefer colorful decorations. And finally, 20 of the responders who pay attention to fashion also prefer colorful decorations in their homes. So this would be 20 in the top left box. Now we know there's 150 people total. We currently have the 105 on the bottom row plus the 20 in the top left box. So that's 125. So if we subtract the 150 total minus the 125 we've already accounted for, that leaves 25 to go in the final box. Now we have 150 people total. We have 70% do not pay attention to fashion. We have 33 of the responders who prefer neutral decorations also do not pay attention to fashion. And 20 of the responders who pay attention to fashion also prefer colorful decorations in their homes. This is our completed box. If you have any questions about this lesson, please use class time to ask for clarification.